In this video, we're going to talk about rational numbers as exponents, fractions as exponents. All right, and that turns out to relate to radicals and what we've been talking about with radicals here. So I'd like to start by having you try these first 8 problems. Let's see if you remember some of your rules of exponents, and then watch the video. All right, so let's look at this. So here you have x squared times x to the 10th. That's going to be x to the 12th. And so we add the exponents. We have what's called the product rule. A to the n, or let's see, a to the m times a to the n equals a to the m plus n. So when you have a product of 2 powers of a, you add the exponents. All right, let's go ahead and do number 5 here because it's very similar to the one we just did. We know that when we have a product, we add the exponents. So when we do the opposite and divide powers, we subtract the exponents. You should have gotten x to the 9th here. 12 minus 3 is how I get that 9. This is the quotient rule. So a to the m over a to the n equals a to the m minus n power. So we subtract the exponents. On number 2, notice we have a power to a power. This is what we call the power rule. And in this case, we multiply the exponents. So a to the m raised to the n power is a to the m times n power. That's the power rule. Or really it's a power to a power, so I call it a power to a power rule. But it's officially known as the power rule. Now, just see if we can make some sense out of this. If you have 2 x's multiplied times a total of 10, don't you have a total of 12? X's multiplied. So you just end up adding the 2 and the 10 as a shortcut. Here, if you had, well, let's use something a little bit nicer, like a to the 6th over a squared. You'd have 6 a's multiplied over 2. These 2 cancel those out. Notice you're left with 4. 6 minus 2, a to the 4th. And so it's pretty clear that these rules are as they should be. You could do something similar here. Multiply 5a cubes and if you just, you have 3 a's, another 3, a total of 5 of these. So that's going to give you 15. So you could add up all the a's that are multiplied. There'd be 15 of them. The shortcut is to multiply the exponents. All right, so the next 2 are variations of what we already have in terms of the power rule. So here you're going to take x squared to the 5th power and y cubed to the 5th power. And so that's going to be x to the 10th, y to the 15th. So this step here is kind of optional. I usually would just multiply my exponents here, the 5 and the 2, to get x to the 10th, and multiply your exponents here, you get y to the 15th. This in-between step is optional. So here it's very similar. We have the numerator to a power, to the third power, so a to the fourth cubed, and we have the denominator b squared cubed. So we're going to end up with a to the 12th over b to the 6th. So again, you could just go directly from here to here. This is kind of an optional step in the middle. So these are what we call the expanded power rules. Expanded power rules. The first one is if you have a times b to the n, then you take each of these to the n power, a and also b. And if you have a over b to the n power, that's a to the n power over b to the n power. So that's the basic idea of what we did on problems 3 and 4. Now we have negative exponents. It turns out that, well, let's just write the rule. A to the negative n power is 1 over a to the positive n power. I always say a negative exponent leads to a reciprocal, where you have 1 over the same number, a to the n. So this is 1 over a to the 4th. Well, what if you had 1 over a to the negative n? Well, that would end up being a to the positive n. We could go through some steps and I can show you that, but what you find is you could think of this as a to the minus n over 1 and just flip the fraction and change the minus n to a positive n. Or another way to think of it is I'm moving this a downstairs and changing the sign of the nth power, the minus nth power. And here I'm moving, because I have a negative exponent, I'm moving it up into the numerator and it becomes a positive n. So for example, if you had like, where am I going to do this? We'll do it up here. If you had a to the negative 1, b to the negative 2, over c to the negative 3, you could just move each of these either up or down in the fraction and change the sign. So it'd be c cubed over a to the first, or just a, times b squared. So anytime you have a negative exponent, the nice little shortcut is to move your base up or down in the fraction and change the sign of your exponent. So here I can move the x to the negative 3 up to the numerator, and it'd be 2x cubed. Now you could write that over 1, but we'd just write it as 2x cubed. All we're doing is moving, all we're doing is moving this x to the negative 3 power up. It becomes x cubed, and so we get 2x cubed. All right, we have one last property. If you have a over b to the minus n, so similar to what we have here, remember that idea of the reciprocal. We flip it, the a over b becomes b over a, and they'll be to the positive n power. So I know that was a quick review of our rules of exponents, but these are the ones you're going to need. So here we can write this as 7b over a squared. So we're going to square 7b, that's 49b squared. And we're going to square the a, that's a squared. All right. So that's just a reminder of some things about our rules of exponents. Let's get into radicals now and how those relate to rational exponents. Exponents as fractions. So if you had 5 to the 1/2 power times 5 to the 1/2 power, since your bases are the same, and you're multiplying two powers of 5, you just add the exponents. 1/2 plus 1/2, that's 5 to the 1 power, or we could just write 5. Well, we also know something about the square root of 5 times the square root of 5. Remember, this is the square root of 5 squared. And we know these are opposites, so if you square the square root of 5, you end up with 5. So this is 5. This is the same as that. So notice if 5 to the 1/2 power times itself is 5, and the square root of 5 times itself is 5, it makes sense that 5 to the 1/2 power is the square root of 5. So I want to make two comments here. Negative exponents lead to reciprocals. And the other comment I want to make is fractions as exponents lead to radicals. So that's good to remember. So notice what we have here. So basically, notice a square root, and it can be written as the radicand, where it becomes our base, to the 1/2 power. So anything to the 1/2 power is a square root. So here's our definition of a to the 1 over n power. So for square roots, this would be 1 over 2. But it's for other roots as well. If a to the nth power is a real number and n is an integer greater than 1, then a to the 1 over n equals the nth root of a. So notice the root is the denominator of the fraction. The other thing I would put here is the special case, a to the 1/2 power equals the square root of a. So here, the denominator here tells me my root, and the x is my radicand. X to the 1/3 power is the cube root of x. 64 to the 1/2 power is the square root of 64. Notice it says simplify if possible. In this case, that would be 8. On the next one, this is the 4th root of 81. We did that one earlier. That's 3. This is 4 times the 5th root of x. Remember, the denominator gives you the root. Now, keep in mind, this exponent only goes with the x since there's no parentheses here. An exponent only goes with the number it's next to or the letter it's next to. If you want it to apply to more, you need a parenthesis. And so that would be our answer there. Excuse me. All right, so here it says, so I'm sorry, I should probably have been a little more clear here. We were rewriting these without rational exponents, basically changing them to radicals and simplifying them if we could. So now we're going the opposite. We're going to rewrite with rational exponents. That's fractions as exponents. So this is 10 to the 1/2 power, since it's a square root. This would be 20 to the 1/3 power, since it's a cube root. Now notice here our radicand is 3a squared b. That's to the 1/5 power. And I'm going to go ahead and stop right here and make a second video.